Okay, here's an active figure that captures the charging circuit. So when I close the switch here to point A, um, it will be a simple RC circuit. So watch how Q as a function of time and current as a function of time looks like. So you see here is the 1 minus e to the minus t over tau for the charge, and here is maximum current times e to the minus t over tau. That's the current in the charging RC circuit, right? So it's clear if I decrease the capacitance, right? If I decrease the capacitance, then C times E will go down. That's the maximum charge will go down. And also R times C, that's the time constant, will go down as well, right? So see if I get the capacitance all the way down here, and I will move the switch to point A. You can see that did not change the initial current at all because the maximum current is E divided by R. All I did was to change the capacitance. So you can see if I make the capacitance large, quite large at 2 microfarads, and leave the resistance as it is and the EMF as it is. When I close this, you can see since the capacitance was higher, the maximum charge is also higher, but that didn't do anything to the initial current. Maximum current is E divided by R. That didn't change. But if I try to increase the resistance as well, right? If you increase the resistance, then the max current will also go down. So you can see that it went down. And also you can see it takes quite long to get up to the maximum value, or the time constant RC is larger, time needed to get up to 63.2% of the maximum value, right? So in the next video, we'll be talking about the discharge capacitor. So now say I leave the switch on for a long time, right? So now this capacitor is completely charged. And if I throw the switch from A to B, then the battery is out of the picture. And then the capacitor will try to discharge through the resistor. Okay, so watch this. Now this is a completely charged capacitor, but if I close the switch here, then capacitor is trying to send current through the circuit. So charge is exponentially dropping, current is exponentially dropping, right? So we'll do the math for it, and we'll show that this is indeed what happens in a discharge circuit.